Hello students, we are studying Internet Protocol Security IPSec and in this video we'll be studying about replay attack protection. So if you remember in the previous videos of authentication header and encapsulating security payload protocol, we have seen that both the protocols are providing the anti-replay protection for IPSec. So here we will see that how exactly the replay attack is protected here in IPSec. So for that, we first understand what is replay attack. So a replay attack is the one in which the attacker obtains the copy of an authenticated packet and later transmit it to the intended destination when the original sender goes offline. So in initial modules also we have seen that how the replay attack is attempted. So here in both AH and ESP protocols, the replay attack is prevented by using the sequence number. So and it also uses the sliding receiver window. So each IPSec header contains a unique sequence number when the security association is established. The number always starts with 0 and increases until the value reaches 2 raised to 32 minus 1. Why it is only up to 2 raised to 32 minus 1? If you remember, in case of AH and ESP both, the size of sequence number field was 32 bits only. And when the sequence number reaches maximum, then it restarts to 0, and at the same time the old security association is to be deleted and a new one is to be created. As we have seen that the sequence number will never be restarted to 0 in the same security association. We have to break that security association and start with the new security association with the sequence number 0. So what is security association? That we are going to study in the further videos. So to prevent this processing of duplicate packets, this IPSec mandates the use of fixed size window at the receiver size. The size of the window is determined by the receiver with a default value of 64. So here in this figure you can see this is a replay window. The size of the window here is W and the window is of fixed size W. The shaded packet signify received packets that have been checked and authenticated. So here you can see these packets from N to N plus W. These packets are marked and they are authenticated packets. So there are three cases here. When the packet arrives at the receiver, one of the three things can happen depending on the value of the sequence number. So these the packets which are on the left hand side are the packets which are discarded, and packets on the right hand side, these are the new and authenticated packet which are marked, and then we can slide the window. So there are three cases. First, when the sequence number of the packet is less than n, then less than n means here when it means that this puts the packet on the left side of the window, and in this case then the packet is discarded. It is either a duplicate packet or its arrival time has expired. Then the second case is when the sequence number of the packet is between n and n plus w minus 1 inclusive. So this puts the packet inside the window. See here, this shaded region, the packet number is inside the window. It is between n to n plus w minus 1. So in this case, if the packet is new, it is not marked and it passes the authentication test, it means that the packet is authenticated at the receiver side, then the sequence number is marked and the packet is accepted. Otherwise, we have to reject the packet. Then the third case is here, the sequence number of the packet is greater than n plus w minus 1. It means that the packet is here on the right hand side. So this puts the packet to the right of the window. So in this case, if the packet is authenticated the corresponding sequence number is marked and the window slides to the